Misra sir. Good evening, sir.
Namaskar, sir.
We will wait for another 3-4 minutes, sir. Then we will begin, sir.
Yes,
Okay, sir.
Yes.
Okay, professor. Okay, professor. Thank you, professor. Thank you. Madam. I think we can
Good evening,
start,
sir.
madam. Good evening,
Okay,
ma'am.
sir.
We can
Okay, sir.
start, madam. You please proceed, madam.
Oh, okay, sir. Good evening, everyone. I welcome all the faculty members and participants of this workshop. Welcome you to the day 4 first session of 5-day online FDP on advanced signal processing communications using AI and ML techniques, which is a joint collaborative workshop by ECE departments of GMR Institute of Technology, Rajam, and Sri Sai Ram Institute of Technology, Chennai. I would like to introduce today's resource person, Dr. Yogesh Misra. Dr. Misra has done his BE in electronics, ME in ECE, and PhD also, and he has a passion towards teaching. He has 24 years of teaching and industrial experience, and currently he is working as professor in ECE department of GMR Institute of Technology, Rajam. Earlier, he worked in automatic electronic control system as engineer, installation and commissioning for many years. Later, in the year 2003, Dr. Misra switched to academics and worked at KL University, Modi University, Rajasthan, and BRCM College of Engineering and Technology, Haryana. He has conducted many workshops for the students as well as faculties on topics related to interfacing and programming of Arduino, circuit designing using PSpice, ORCAD, PCB designing and fabrication, application of VHDL in system design, microprocessor and microcontroller programming, VLSI embedded computing, embedded system design, FPGA architecture and applications, fuzzy logic and its applications. He has also delivered lectures in AICTE, ISTE refresher programs and UGC sponsored seminars. He has published more than 30 research papers, and majority of his papers are in the field of VLSI design, soft computing and embedded system. Dr. Misra has also authored a few books, and some of them are Programming and Interfacing with Arduino, so which is in production from CRC Press, Tyler and Francis. And another book is Digital System Design Using VHDL from Dhanpat Rai Publication, India in the year 2006, and Application of Soft Computing in Improving the Efficiency of Sugar Making Process from Lambert Publication in the year 2017. Dr. Misra has been declared as one of the toppers in the microprocessors and microcontrollers course conducted by NPTEL IIT Kharagpur. And Dr. Yogesh Misra has developed the following lecture series, which are available on udemy.com with certification. So they are System Design Using Verilog and Arduino Programming and Interfacing. Dr. Misra, sir, welcome to this workshop, sir. We are happy that you are sharing your knowledge to all our participants. Now the session is yours, sir. Thank you very much, sir.
Thank you, madam, for reading out my profile. And I also want to welcome all the participants on this workshop, on this faculty development program. Okay, I will share my screen first. Okay, my slides are visible.
Yes, sir.
Okay, so this is a 5-day online faculty development program on advanced signal processing communications using AI and ML techniques. So on day 4th, session 1, actually, if we talk about signal processing, then basically first thing is we need sensors. Then we have to sense the signals, and then we have to do the processing. So the topic Yeah. So the topic which I have selected is sensors, sensing and processing. So I will keep the things very simple and I will try to make this presentation enjoyable for all of you. So here what I will do, I will discuss about few sensors, their parameters, their characteristics, and how we can sense the signals from those sensors and we can do the processing. So for this purpose, for the processing purpose, I will demonstrate the Arduino board, which is very common board nowadays, and it is very popular due to its low cost and the availability of the softwares or the integrated development environment which is required to develop the program. It is freely available on the internet. Due to that, it is very much popular, not only among the students, even for the product development also people can use this board. So I will use basically that Arduino board and different sensors, their parameter, characteristic and how to sense. And I will also try to give some flavor of the programming of this Arduino by using this embedded C. So the flow of this presentation will be like this. I will just demo 5 minutes like that for the features of the Arduino board. Then ADC and analog pins of Arduino. Then directly we will go to the temperature sensor. Then how we can display it, the value of the temperatures. Then ultrasonic sensor, smoke sensor. Then here we will use the relay, right, which is basically used to interface a low voltage device with a high voltage device and to run the actuators. Then light dependent resistor, optical sensors, touch sensor and humidity and temperature sensor. So if we talk about the processing boards, so this is one board which you are seeing on your screen. It is from ST Microelectronics, right? So the name of this board is STM32F401 Nucleo ARM Development Board. So in this board, there is an ARM processor is there. Here there is an ARM processor. So this board is also very much popular, but it is somewhat costly. It comes in around 6,000-7,000 rupees. And to develop the programs, we have to use one online software platform, that is Embed C platform, right? So directly through online we can develop the programs. Now another board which is very much popular and very much low cost, that is Arduino Uno. So in this Arduino Uno, it comes in the market in the range of 500-600 rupees, and its software is freely available. We can download the software in our workstation and we can develop the programs for it. So in this board here this IC is our processor. This is our processor, and it is at Mega 328. This is the part number at Mega 328, and this board, it operates at the frequency of 16 megahertz. Now to turn on this board, there are basically three methods. One, from this is USB connector. From this directly we can connect to the computer and it will get the supply, or from here we can connect the adapter. This is the second option. And another option here is this V-in pin, right? This V-in pin. Here also we can apply plus 5 volt. Then also we can turn on this board. Now this board Here you can see there are few pins named as A0, A1, A2, A3, A4, A5. These are 6 analog input pin. Analog input pins. So from these pins, generally we connect the sensors from to these pins, right? So generally, if we see any sensor, then this sensor, suppose this is one sensor. So it senses the environment. It senses the environment and it generates, generally it generates analog signal. And this analog signal we have to sense. So for that purpose, we have to connect these output of this sensor to these analog input pins. So here in this Arduino board, total 6 sensors we can connect. But ultimately this processor is a digital processor. It will process on the digital data. So this analog signal which is received from these analog inputs, internally in this processor, in this Atmega 328, there is internal A to D converter is there. There is internal ADC. ADC is there. I will talk about that ADC because that is very important to understand the working of that ADC. And then only we can understand how exactly this board is sensing the analog signals which are coming out from the sensors. So there is one ADC, internal ADC is there. That ADC will convert the analog signal which is actually equivalent to the some parameter of the environment, maybe temperature, pressure, humidity, right? And that analog signal is converted in digital form, and finally that digital data will be processed by this processor depending upon the application program which we have written. So processing will be done as per our application program which we have developed. Sensing will be done through these analog pins, and internally before the processing, these analog signals has to be converted in digital form. Okay. Now this side we can see there are few pins which are named as 0, 1 and up to 13. So these are 0 to 13. Total 14 pins are there, and these are our digital pins. These are digital pins. Now these digital pins are programmable, means we can program these pins as input pin or as output pin. So if we want to connect any output device to these digital pin, then we can program it as a output pin. And if we want to connect any input device example is some switch, then we have to program it as a input. So that programmable feature is available. You can program any pin as a input pin or output pin. But these pins generates digital signals. Either it will generate 0 volt or it will generate 5 volt. 5 volt for binary 1 and 0 volt for binary 0. But there are few pins which are having dual function, right? You can see here this pin number 3. In front of pin number 3, you can see this symbol. This symbol is there. This type symbol is there. So same way at pin number 5 also you find same symbol. Pin number 6 also, 9, 10, 11. So 1, 2, 3, 4, 5, 6. There are these 6 pins, and these 6 pins are having PWM capabilities. PWM means pulse width modulation capabilities. So see, since these pins, I told you these are digital pins, pin number 0 to 13. So we can generate only either 0 volt or 5 volt. But suppose in some application you want to generate some analog signals, analog voltage in the range of 0 to 5 volt, right? Suppose we want to generate 1.2 volt or we want to generate 3.7 volt. So these are definitely analog signals. These are not digital. So in Arduino board, we can generate these analog signals also, but for that we don't have DAC, digital to analog converter is not there, right? So, but still we can generate analog signals, but for that we use pulse width modulation technique. By using pulse width modulation technique, we can generate the analog signals in the range of 0 to 5 volt in this board. Okay. Okay, these are important pins only, and few you can see here. There are two pins. One is 3.3 volt and another is 5 volt. So from these pins, from 5 volt pin, a 5 volt signal, we can get 5 volt signal. And from 3.3 volt pin, we can get a signal 3.3 volt. This output we can get. So we can use these voltages in our external circuitry also, right? So there is no need to develop some separate power supply for that. Directly from here we can take the 5 volt or 3.3 volt and we can use those voltages. And there are these ground pins, two ground pins are here, and there is one ground pin this side, right? These are here. Okay, now with this background I will move to the next slide. Now we will come to the ADC pins, because here these pins are very much important, because if we are sensing the sensors, we are sensing some value from the sensors, then generally most of the sensors, they generate the analog signals. So we should know about this, the functionality of this. Okay, so now here these six are the analog input pin. Suppose at A0 we have connected some output of some sensor. Now the analog voltage which we can apply, which can enter in this Arduino board through these pins, are in the range of 0 volt to 5 volt. In this range, any analog signal can enter in the Arduino board. And once the signal will enter inside the analog, inside the Arduino board, then there is one internally, one electronic hardware is there, and that is your analog to digital converter, right? So this analog signal will go to the analog to digital converter. And this ADC is 10-bit ADC, right? 10-bit ADC. 10-bit ADC means it generates 10 digital output with reference to the analog input. So here we have analog input. So this is analog input, and D9 to D0. These 10 digital output will be generated through this ADC. And this is a 6-channel ADC. 6-channel ADC means 6 different analog signals can be connected, right? And it will convert in digital form. Okay. Now there are few important terminologies related to this ADC. We must aware about those terminologies. First is number of steps. Number of steps. And this will be given by 2 raised to the power n. This is the formula where n is number of digital output lines. Number of digital output lines of ADC. So here in this example, in this Arduino board, we are having ADC of 10 digital output lines. So 2 raised to the power 10, it will give me 1024. So this ADC is having 1024 steps, right? So steps will start from 0. So step number 0, step number 1, step number 2, like this. The last will be 1023 steps. So total steps of this ADC is 1024. that is 0 to 1023. So this 1024 we got from this relation 2 raised to power n, where n is the number of digital output lines of the ADC. Now another important point here is step size. What is the formula for getting the value of the step size? It is maximum allowed input analog input voltage. How much maximum analog input voltage which we can apply to this ADC. So as I have just explained to you, we can apply an analog signal in the range of 0 volt to 5 volt. So maximum voltage which we can apply is 5 volt. Divide by number of steps. So steps already we have calculated. It is 1024. So if we solve this, then we got this value 4.9 millivolt. This is the step size. 4.9 millivolt is the step size. Now, if I want to define the step size, then in very simple term, I can define it in this way. Step size is the minimum analog input voltage which is required to send the digital output to next consecutive state, right? Suppose let us assume the digital output right now we are having 0, 0, 0, 0, 0, 0, 0, 0 and 0, 0, right? This. And what is the next state? Next state is 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. This is the next state, right? From this state to this state, the digital output will go if 4.9 millivolt input signal is applied. It is getting 4.9 millivolt. Then only it will go to the next state. Otherwise, it will not go. So this is the step size. Now with this, now here you can see in this table, here I have mentioned digital output of the ADC. It is D0, D1 and up to D9. These are the 10 digital output lines, right? Step 0. Step 1 means it starts from step 0 and last is step number 1023. So total 1024 steps. So let us assume here for step 0, the digital output will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, right? Now let us assume if the analog input which is coming to this from some sensor is, let us assume it is 2 millivolt, right? It is 2 millivolt. Then what will happen? Whether we will get a digital output some other value? No, digital output will not change. It will remain same 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. If we receive a analog input from some sensor of value 4.8 millivolt, just slightly greater than 4.8 millivolt, then the digital output will become, it will go to the next state, that is 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. And that is my step number 1. So if we are in step number 1, this means that the analog input is definitely greater than 4.8 millivolt. Then only it will go to the next step. Now again, from step 1 to step 2, when it will go? When the analog input voltage is in this range, 9.8 millivolt to 14.7 millivolt, then it will be next state, means 0, 0, 0, 0, 0, 0, 0, 0, 1, 0. In this way, if the analog input is 5 volt, then we are getting 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. All 1 will be the output of the ADC. So in case of Arduino, the analog signal, whatever is received from a sensor, is represented in terms of step number, right? It is represented in terms of step number. So this is the important thing, because when we are sensing some data, we should know how it is accepted by certain processing unit. So in this processing unit, it is in terms of the step number, and we have to identify with reference to particular step what is the analog input. So now we can identify very clearly. So suppose if the step is 512, this means around 2.5 volt is received at the analog input. That's why the step is 512 volt. Okay. So with this background, we move to this temperature sensor now. So here this is a very popular temperature sensor which is available in the market, LM35. Many students, they use this temperature sensor in their projects also. It looks like a transistor, very small device. It has 3 pins. Pin number 1 has to be connected to the DC voltage in the range of 4 volt to 20 volt. Pin number 3 should be connected to ground. And pin number 2, from pin number 2, we get the output analog signal, which is as per the surrounding temperature. For example, if the temperature is suppose 0 degrees Celsius, then the output voltage we are getting 0 volt. But if the temperature is 1 degree Celsius, then this pin number 2, from here we will get 10 millivolt. Right? This voltage we will get. If the temperature is 2 degrees Celsius, then we will get 20 millivolt. Means for each degree rise in temperature, this IC generates 10 millivolt. So if we are having suppose 40 millivolt, if we measure the voltage at this pin number 2, it is 40 millivolt. This indicates that the surrounding temperature is 4 degrees Celsius, right? So if we connect this pin number 2 to A0 pin of our Arduino, so Arduino will receive the analog signal, which is equivalent to the surrounding temperature, right? But that analog signal, so suppose if we receive here analog signal 40 millivolt, but now this 40 millivolt directly cannot used by the processor of the Arduino, because that processor is a digital processor. That's why this value has to be converted in digital form. Then we can process that. But in digital form, it will be whatever analog input we are getting, so it will be represented in terms of the steps. From that we can identify how much value is entering. So we can see this here, how we can connect this LM35 with this Arduino. So as I said, this pin number 1, we connected to 5 volt. Because we can connect it in the range of 4 volt to 20 volt DC. Pin number 3, we have connected to the ground pin of this Arduino. And pin number 2, which is the output pin, this I have connected to A0 pin of this Arduino board. Now here one thing. Now this is the program here. So I will not go in much detail in this programming, but few things only I will tell you. You can see here, I have given the name to this A0 pin as analog voltage, and this is one function pin mode. Right? This is one function pin mode, and here I am declaring this A0 pin as an input pin. Now after that there is another function I have written, serial.begin. Basically I am writing this function only to display the temperature in the serial monitor of my computer, right? For that purpose I am writing this function. Now we come to this loop. Inside this loop, the main logic of our program is there in this loop. In setup, see, this is the setup part. Arduino program is having two parts. One is setup, another is loop. In setup, we write those statements which are required for the initialization purpose. So since we want to initialize A0 pin as an input pin, so that we have done in setup part. But the main program will be in loop part. So now here you see this first statement, what I have written, analog read. Analog read is a function of this embedded C program. This function will read the value of analog pin, which I have written here inside the bracket. So this function will read the value of analog pin A0, right? So as I said, when we are reading the analog pin value, then it will be represented in terms of steps, right? So steps are from 0 to 1023. These are the steps, and these are integer numbers. That's why here what I did, I have declared the integer. Int is for the declaration of the integer. I have declared the integer named as step. So this step will have a value in the range of 0 to 1023, depending upon the analog signal which enter inside this A0 pin, right? So first we will read this analog read A0. It will read the value of analog pin A0, and whatever analog voltage is there, equivalent to that, whatever the step size, that will be stored in this step. That value will be stored in this step. So value of the step will be 0 to 1023. But that value has to be represented in terms of the temperature, right? What temperature is there in the surrounding atmosphere, that we have to calculate. For that, what I have done here, you can see whatever step I have sensed, that I have multiplied by this number 0.48828125. So once you multiply that step with this, you will get the temperature, right? But the question is how this value has come, 0.48828125. This is the important thing, how I got this value. So I will explain how I got this value. You see, suppose 1 degree Celsius will be represented by 10 millivolt, right? In LM35, 1 degree Celsius will be represented by 10 millivolt. Or I can say that if there is 1 millivolt, then the temperature will be 1 divided by 10 degree Celsius. So this is 0.1 degree Celsius, right? So 10 millivolt represent 1 degree Celsius. So 1 millivolt will represent 0.1 degree Celsius. Now we know that step size is maximum allowed input voltage to this analog signal. This is 5 volt. Divide by total number of steps, 1024. If we solve this, then we get a value. So I am just dividing this. So 5 divided by 1024. If we are dividing, then we are getting 0.00488282125 volt, and I represent this value in terms of millivolt. So it will be 4.88282125 millivolt, right? So this is the step size, millivolt. So now again we come back, 1 millivolt represent 0.1 degree Celsius. Therefore, 4.88282125 millivolt, it will represent 0.1 multiplied by this. So it will be 0.488125 degree Celsius. And this 4.88282125 millivolt, this is one step. This is one step. So basically, one step represent this much temperature, right? One step represent this much temperature. So if our this Arduino board read a step value, suppose 3, it read the 3 step, then what is the temperature? One step represent this temperature, so 3 step will represent multiplied by 3 with this. So same thing I have done here. Step, whatever is the step, this we have received in by the previous statement. Then we are multiplying with 0.48828125. With this I am getting the current surrounding temperature, and that result I am storing in a variable, this temp, which I have declared as float time, because there is a possibility that I will get a temperature in decimal also, 28.3, 24.5. So that's why I have declared it as a floating type number. Okay. So with this statement, by these two statements, I will get the surrounding room temperature. Now after that, I have written 2-3 statement only for representing that temperature in my serial monitor, right? Only for that purpose I have written. So we will not go in detail of those, but the main logic is first 2 lines, right? In this way we will get the temperature. Now I will just show you this whatever I discussed just now. So I will just demonstrate. Okay, this. So now I will show you the demonstration of how we can interface LM35. So please, someone can respond me that whether you are getting the voice of this video also.
Yes, sir.
Okay, thank you. So now I will show you the demonstration of how we can interface LM35 IC. Now LM35 IC, it is a temperature sensor, and you can see this IC. This is a temperature sensor IC. It is having 3 legs. Okay. So leg number 1 is to be connected to +5 volt. Leg number 3 is to be connected to ground, and the middle leg is used as an output, which is analog in nature, and we convert that value into equivalent temperature. So now you can see here in this circuit, here this is a temperature sensor IC. This green wire is connected to pin number 1, and it is connected to the VCC of your Arduino board. Then this orange color wire is at pin number 3, and this is connected to the ground of our Arduino, and middle wire is connected to A0 pin, that is analog pin of our Arduino board. So now I will connect this Arduino to the computer. I will dump the program, and in this particular program, the temperature, room temperature, will be displayed on the serial monitor. So then now you can see in the serial monitor the room temperature. So I will dump the program first. program has been uploaded, and now you can see the temperature which is coming on the screen. You can show here. See the room temperature. It is coming. Room temperature is equal to 27.34 degrees Celsius. So, in this way, we can display the temperature on serial monitor. Now here in this second case, what I have done, same connection. I have used the same LM35 and connection is also same here in this side. Now only thing what I did, instead of displaying the temperature on my computer, I have connected here one LCD, right? So now with this board we are having two devices. We connected two devices. One is the sensor, whose value we are processing through this Arduino board, through this processor, and finally the processed data we are displaying on the output device, which is LCD here, right? So again, I will not go in the detail of this LCD, why I have connected in this way, but if you can find those things in the literature. I will just demonstrate you. Here also, if you see the program is, see, main program you can see here. These two statements already we discussed in the previous case. With these two statements, we are converting the temperature, surrounding temperature, into degrees Celsius, right? By using the processing the analog signal, and we are storing it in the variable temp, right? Later on, I have written some statement. With these statements, I am simply transferring that temperature value to the output device, right? And in that few statements I have written for that LCD. Here, these are few statements related to the LCD only. Otherwise, the main program is lying in these two lines only. Okay, so this also I will demonstrate how it will come on the LCD. So in last lecture we discussed about LM35 IC. The basic function of LM35 IC is to measure the temperature. It is a 3-pin IC, and the pins are like this. This is LM35 3-pin IC. Pin number 1, 2, 3. Pin number 1 is VCC, where we have to connect a DC voltage in the range of 4 volt to 20 volt for the operation of this IC. Pin number 3 is ground, and pin number 2 is an output pin. Now, depending upon the surrounding temperature, this IC generates output voltage at pin number 2. If for each 1 degree Celsius, this IC generates 10 millivolt. So this is LM35. This IC is LM. Black covering is pin number 1, then pin number 2, and pin number 3. So now what I have done, now in this circuit diagram, you see, bring here, focus here. In this circuit diagram, I have already connected this. This is LM35 IC. So this is the total circuit. Now I will display the current room temperature in this LCD display.
Now you can see here. It is coming. So it is written room temperature 21 degrees Celsius. It is varying 21.00, 20.51 like that. Right now, what I will do? I will hold this LM35 IC so that my body temperature, with my body temperature, some heat is transferred to this LM35 IC. So now you can see the temperature has been increased. It is now 29 degrees Celsius, right? It is now 29 degrees Celsius. Now if I release this IC, now slowly it will come back to 21 degrees Celsius. Slowly it will come back. Now it is 26, 25, right? Slowly it will come back to, now it is 24, 23, 22. So now if you again, now you see, again I will touch this LM35. Now you see what will happen. Again temperature is increasing. So it is now sensing my body temperature, right? By the heat of my body, I am transferring that heat to this LM35, so the temperature is rising, right? Okay, so this is about LM35 IC, which is used for the measurement of the temperature.
Okay, now we will move to another sensor. This is ultrasonic sensor. Now, this sensor is used to detect some obstacle, and not only detection. With this, even we can calculate how far is that obstacle from this sensor. That also we can calculate. So in this ultrasonic sensor, so basically this ultrasonic frequencies, they are above 20 kilohertz. Now this sensor detect object in the range of 2 centimeter to 450 centimeter from the sensor. If any object up to 450 centimeter, it can detect the presence of that object. So here in this sensor, you can see this circular type of thing. This is one transmitter. It transmits the ultrasonic signals. So in sensor also you can find it is written as here T. This is transmitter. And this side you can see here it is written R. So this is the receiver. It will receive the ultrasonic signal which are deflected back by the obstacle, right? So and here you can see there are 4 pins. 4 pins are there. This pin is VCC. We connect this with the 5 volt DC supply, and pin number 4, this is ground. This has to be connected to the ground. And in between there are 2 pins. One is this trig. It is written as TRIG, trig. Now to operate this ultrasonic sensor, what we have to do? First, we have to give one pulse. This pulse we have to give, right? High pulse. This is a high pulse of 10 microseconds. Of this duration pulse we have to apply to this trig input. Then only this ultrasonic sensor will start working, right? So this is the first step. We have to apply one 10 microsecond high pulse to the trig input. Once this pulse is applied, then this transmitter transmits 8 ultrasonic pulses. 8 ultrasonic pulse. 8 pulse it will generate, right? Now, if suppose there is any obstacle in this range up to 250 centimeter in front of this device, then the ultrasonic pulse will be reflected back from that obstacle, and it will come back to this receiver, and receiver will receive that. And if there is no obstacle, then these pulse will simply go away. It will not come back to the receiver section. Okay, right. Now here you can see the same thing what I explained. Here this is my transmitter, and this is the receiver. And transmitter, it will start generating the ultrasonic pulses, and if there is an obstacle, then these ultrasonic pulses will get deflected back from the obstacle, and it will be received by the receiver. And now, so already we discussed about pin number 1 and 4. These are VCC and ground pins. And trig, pin number 2, trig. As I said, a high pulse, that is of 5 volt, of 10 microsecond duration must be applied to trig pin to start the generation and transmission of ultrasonic pulse from the TX, right? Now there is another important pin, this one. This is a ECHO, echo pin, right? So what this echo pin will do, in programming we will use one function, and due to that function, how much time a ultrasonic pulse is taking for this traveling of this distance from transmitter to obstacle, and again from obstacle to receiver. The time taken by the ultrasonic pulse for this traveling, for that duration, this echo pin will be high. It will be high for that duration, right? So if you see this high output, for how much duration this echo pin is high, this will give you one information, that how much time is taken by the ultrasonic pulse from its generation of the transmitter section, and after getting the deflection from the obstacle, and again it is received by the receiver. So how much total time is taken? For that duration, this echo pin will be high. So here we can see this echo pin. This pin sends the information about the time taken by the ultrasonic signals from its transmission point. Okay, so total how much time is taken, and it captures by the receiver after it gets reflected by the obstacle. But what is the algorithm behind the calculation of the distance? We come to this slide now. So suppose here we want to develop one system. In that system, we want to generate some warning sound or some indication whenever an obstacle is detected within 20 centimeter range from the ultrasonic sensor module. Then we want to generate some alarm or some warning sound type of system, or some indication by using some LED. If there is any obstacle within 20 centimeter range, right? So the algorithm will be like this. First, we will initiate the ultrasonic sensor module by sending a pulse of 10 microsecond at trig input pin. Then the second step, transmitter section of ultrasonic sensor module generates 8 pulses of 40 kilohertz frequency. So the frequency of the pulse generated by the ultrasonic sensor module will be 40 kilohertz and 8 pulses will be generated. If obstacle is detected at 20 centimeter in front of the ultrasonic sensor, whether it is detected or not, if yes, then we will generate some sound through the buzzer, or we can glow the LED, which will indicate that something is there. And if there is no obstacle, then again we will come back to this point, right? And same process will continue. So here you can see the arrangement of the circuit. This VCC of the ultrasonic sensor we have connected to 5-volt pin of the Arduino. This ground pin of the ultrasonic sensor we have connected to the ground pin of the Arduino. Now the trig pin, you see the trig pin. So basically this trig pin is the input pin of the sensor, but it is the output pin of the Arduino. From the Arduino we have to generate one pulse of 10 microsecond duration of high period, 10 microsecond. Then only the transmitter will start transmitting. Now you see this echo pin. Echo pin is the output pin. It is the output pin of the ultrasonic sensor, because this echo pin will generate a signal, a high pulse of the duration, which is of the total duration of the time which is taken by the ultrasonic pulses to travel from the transmitter and again up to the receiver after the reflection from the obstacle. So this echo pin should be output. So if it is output, then in Arduino it should be, this pin number 11 should be input pin, because whatever information we are getting from the echo pin, we should receive that information, right? So pin number 11 should be input, pin number 13 should be output. Okay. Now the algorithm to calculate the distance. Step 1. The TX will emit 8 ultrasonic pulses of 40 kilohertz frequency. Now we come to this second point. Now here we know that the speed of ultrasonic pulse in air is 340 meter per second. This is known to us, and this we will write in centimeter per microsecond. Then it will be 0.034 centimeter per second. This is the speed of ultrasonic pulse in air. So 0.034 centimeter per microsecond. This means ultrasonic waves cover 0.034 centimeter in 1 microseconds. So ultrasonic waves will cover 1 centimeter in 1 divided by 0.034 microseconds, and 20 centimeter. So simply multiply it by 20. So we get here one value, 588 microsecond. So in 588 microsecond, ultrasonic sensor will travel a distance of 20 centimeter. This we have calculated. Now we can see here, suppose this is our sensor and this is some obstacle, right? So from the sensor, this obstacle is at 20 centimeter. Let us assume it is at 20 centimeter. Then this obstacle, this ultrasonic pulse, it will take 588 microsecond to reach from sensor to obstacle, and after reflection again it will go back, right? Again it will go back. So again it will take 588 microseconds. This means total time taken by the ultrasonic pulse from transmitter to receiver is 588 microseconds multiplied by 2. So this is 1176 microseconds, right? So now we see this echo pin. What I said, echo pin will remain high. It will remain high for how much duration? It will remain high for 1176 microseconds. If an obstacle is at 20 centimeter, then it will high for 1176 microseconds, because total duration we have to calculate. How much time from transmitter to obstacle and obstacle to receiver. For that much duration, echo pin will be high. So now that information we will get, right? We will get this information from this echo pin, and it will enter in our microprocessor. This information we can get from pin number 11, but we will get here, we will get a total time, that is 1176 microseconds. So internally what we have to do, we have to divide it by 2. Then only we can get that distance, right? Because so we have to divide it by 2. Only one side distance we need. So once we divide it by 2, we will get 588 microseconds. This much time is taken by the ultrasonic pulse. And we know for 1 microsecond and for this speed is this 0.034 centimeter per microsecond. So this we multiply with this. Total time taken 588 microsecond multiplied by 0.34 centimeter. So we will get the total distance of the object which is in front of that ultrasonic sensor, right? So here I have written that program. The main important thing which you should just concentrate here, this pulse in, this is the function, pulse in. This function is related to echo pin, right? And here I have written high, right? And this is echo output pin. Echo output pin, basically I have declared pin number 11 of my Arduino, because I have connected echo pin to the pin number 11 of the Arduino. So basically this pin number 11 of the Arduino, this will be high. This will be high for that much duration, which is taken by the time taken by that ultrasonic pulse to travel from transmitter to receiver, right? Okay, and here in next what I have done, once I have calculated that time, so that time was 1176, right? That microsecond. So that I have divided by 2, and after that I multiplied it by 0.0344 centimeter. With this I will get the distance. I will get the distance, and if the distance is calculated distance of the object is less than equal to 20 centimeter, 20, then I will make the buzzer high. Buzzer warning will come, or I will connect the LED, then that LED will glow. This indicate that distance of the object is less than. So here I have used this less than equal to 20. With this condition, I will detect the object, whether it is at less than 20 centimeter, or if it is more than 20 centimeter, then else condition. What it will do? It will make the buzzer low. No buzzer will give the siren, or there is no LED will glow. Okay. So I will just show you this program. Okay, so now I will demonstrate the working of ultrasonic sensor. Okay, so here you can find there is ultrasonic sensor. This is ultrasonic sensor. It is interfaced with this Arduino board. Now you can see here in this ultrasonic sensor, this is the transmitter section from where ultrasonic waves are transmitted. And here this one is the receiver section. It receives the ultrasonic wave which are coming back after the reflection from an object. Now this brown color wire, it is connected to trig pin of the ultrasonic sensor, right? And this wire in Arduino board, it is connected to pin number 13. It is connected to pin number 13 of the Arduino board, and pin number 13 is the output pin I have declared in my program. So this Arduino board, from the pin number 13, it generates a pulse of 5 volt for a duration of 10 microsecond. Then only our this ultrasonic sensor will turn on, will start emitting the ultrasonic waves from the transmitter. And so these waves start coming out from the transmitter, and if there is an obstacle, it will be reflected from the obstacle and returned back, and these ultrasonic waves are received by the receiver. So there is a pin in the ultrasonic sensor that is a echo pin, and that pin will remain high for the duration taken by the ultrasonic pulses for traveling from transmitter to receiver, right? How much time it will take for the traveling from the transmitter to receiver, for that much duration echo pin will be high, and that echo pin of the ultrasonic sensor is connected through this yellow color wire, and it is connected to pin number 11. You can see pin number 11 is connected with this yellow color wire, and pin number 11 in the program is declared as an input pin. So
Sir, a
from
lot of
this
noise
pin,
is
we can
coming.
find
That's
out
why
what is the time
hear,
taken
sir.
by the ultrasonic wave. Noise is coming.
Yes, sir. Some lot of voice is coming, sir.
In previous videos also voice was coming, lot of noise.
How is it okay, madam?
For traveling, the Kanam sir, you are also getting the noise.
Yes, sir. At sometimes I'm muting the part. Those who are opening their mic, I'm just muting them, sir.
Okay, sir.
Yes, sir. Yes, sir. I'm doing that
Total
job. You
distance.
please carry on.
Accordingly, we
Yes,
can calculate the distance. So here in this program, I have written the program in such a way so that if any obstacle I find in front of this ultrasonic sensor in the range of 20 centimeter, then there is one LED, right? You can find there is one LED. This LED will turn on if any obstacle is there in front of the ultrasonic sensor for in the range of 20 centimeter. Right now, in front of ultrasonic sensor, wall is there in my room, and the distance between wall and the ultrasonic sensor is around 55-56 centimeter. And this you can see in this serial monitor. Here you can see it is a 56, right? So this distance is the distance of the wall from the ultrasonic sensor. And right now you can observe that this LED is not on because there is no obstacle in the range of 20 centimeter. Now I will bring my hand in front of this ultrasonic sensor. Now you see this LED, it is turned on, right? It is on because now my hand is in front of ultrasonic sensor, and distance of my hand from the ultrasonic sensor is around, it is 12 centimeter. So you 10 centimeter. You can see here in this screen. It is showing yes, this 10 centimeter. It is a distance. Now you see I am just here only. You focus here only. Now, okay. Okay, so now I will just come to this smoke sensor here, or it will sense the presence of some gases also. So it is MQ2. 1 minute.
Participants, please mute your mic. Participants, please mute your mic.
Okay, so here in this MQ2 smoke sensor, uh, it is also called as gas sensor, and it can be used to sense LPG, smoke, alcohol, propane, hydrogen, methane, and carbon monoxide concentration in the air, anywhere between 200 ppm to 10,000 ppm. So here this ppm means parts per million. For example, if I say 1000 ppm of carbon monoxide, so it means that if we could count a million gas molecule, then 1000 of them would be of carbon monoxide, and remaining molecules will be of some other gas. So basically this MQ2 is a semiconductor based gas sensor. So basic logic is based on the semiconductor, in which the gas detection is carried out by a change of the resistance of the sensing material when the gas comes in contact with the sensor. So when the gas will come in contact with this sensor, then the sensing element resistance will change. That is the basic principle behind this. So here we can see this. This is the back side of this sensor. Here there is one sensing element. This sensing element is there, right? And there are some connecting legs like leg A, leg B, leg this H, right? From this leg A, some analog voltage will be generated depending upon the concentration of some particular gas. Okay, so two leads H are responsible for heating the sensing element. So basically this sensing element, this has to be heated first, right? So that work is done by this leg H. Now the remaining four leads A and B are connected to the body of the sensing element. The sensing element, this sensing element is made up of aluminum oxide with a coating of tin dioxide. So now here basically what happens, suppose this is our sensor. This is our sensor. So this sensing element will be first heated. It will be heated. Sensing element will be heated, right? So surrounding is the oxygen is there in the surrounding, right? So now this oxygen is absorbed at the surface. This oxygen is absorbed at the surface of this sensor. Now this oxygen is clean air here, and this oxygen will attract the electrons from the tin dioxide. So tin dioxide coating is there over the sensor. So tin dioxide will donate its electron to the oxygen, right? So in clean air, donor electrons in tin dioxide are attracted to oxygen. So now due to the donor donating of the electrons by the tin dioxide, what will happen? This process will decrease the number of free electrons in tin dioxide. Number of free electrons will decrease, and thus it will stop. It will prevent the electric current flow. Now, in the surrounding, if there is some combustible gases are there in the surrounding, then oxygen will react with that gas, right? It will react with that gas, but before that, it will release back the donor electrons, which previously it attracted from the tin dioxide. It will release back. So once the donor electron will come back, then again suddenly the current flow will again increase, right? So in this way, this sensor works here. And if we see the connection with the Arduino, I have connected in this way. This VCC pin I have connected with this 5 volt, and there is one ground pin. This I have connected with the ground pin of the Arduino. Now this analog signal A0 pin, it is generating the analog signal with respect to the surrounding availability of the gas which we are detecting. According to that, some analog signal will be generated, and it is connected to A0 pin, right? And here we can change the sensitivity of this gas sensor also by writing a program in suitable way. We can change it. Suppose, for example, if we are using this sensor to sense the LPG gas leakage. So in that case, up to what concentration the gas is available in the surrounding atmosphere, that concentration level also we can adjust with the help of this sensor. Means if gas is, suppose less amount of gas is there, and we don't want to detect that, so we can write the program in that way also, right? And if suppose the concentration level of that gas is more, only we want to detect a particular concentration level, then that can be done in that way, right? So here this is the program here, but in this program one thing we can see here, this logic. First one, sensing element of gas sensor must warm up for 20 seconds to start the gas sensing. So as I said, sensing element we have to warm up. So for the 20 seconds, for that purpose, I have written here this statement. You can see I have written delay 20,000. So 20,000, whatever value I have written here, it is in milliseconds. Right? It is in milliseconds. So 20 millisecond is our 20 seconds. So after execution of these two statements, when the third statement will be executed, so our program will stop here for 20 seconds. And right, so during that period, our gas sensing element will warm up. After that only the program will come to the loop where we are having our main logic of our program. So here you can see this. I have written analog read MQ2, right? So with this, what will happen? Whatever is the value of the analog voltage at A0 pin, it will be sensed and it will be stored in this variable sensor value in terms of number of steps, which I already explained earlier. Steps are from 0 to 1023. In terms of this step only, the analog voltage will be stored here in this sensor value, in this variable. Now I have written this statement: if sensor value is greater than 20, so 20 is the number of steps. If this is the case, then I will make the buzzer or LED high to indicate that some gas is detected, right? Otherwise, it will remain low with this statement. Okay, so I will just demonstrate you this one. Okay, now I will demonstrate smoke detector sensor. So here you can see this is a smoke detector sensor, and it is interfaced with the Arduino board. Now in this smoke detector sensor, to operate this we need a 5 volt and one ground connection. So ground connection is provided by this red color wire, right? It is connected from the ground, and here this green color wire from the Arduino. This is a 5 volt output pin, output signal, and it is connected to the VCC pin of this sensor. Now this sensor will detect the smoke, and accordingly it will generate some analog signal, and that analog signal will enter in the Arduino board to pin number A0. So you can see this yellow color wire. It is connected to this analog output signal of this smoke detector, and it is connected to the A0 pin of this Arduino board, right? So I have, after the experimentation, I have written this program, and now you can see here. You can show this. Right now, it is displaying in the serial monitor that smoke is not detected. Now I will bring this smoke near to this sensor, right? And LED is there. When the smoke is detected, this LED will turn on. Now you see, smoke is detected, so LED is turned on. Again, I will. Yes. Now whatever whoever students they were sending earlier, those problems. It was written that I am having all these details. Smoke detected, right? So no, nothing. In this way, the smoke can be detected by this sensor. Yes. So in some cases, students not joined. Right, and in some cases grade was only 48%. It was in progress, so certificate not issued. कोई नहीं है मेरे वजह से कुछ नहीं है सर. नो ऐसा कुछ नहीं, ऐसा कुछ नहीं. हाँ अभी सब बोल. हाँ हाँ हाँ. Okay, now I will just discuss something about this relay, because it is used for operating the actuators. Depending upon the sensed value. So here, this is the image of the relay. Here we have basically 3 pins which are connected towards the high voltage device, like NC, NO, and this pole. Pole is also sometimes called as common. So we see this here in this diagram. This is common. This is NO, normally open. This is NC, normally closed. And there is one strip which is made up of a material which can be attracted by magnetic field, right? So this strip is normally when this relay is not triggered, when it is in off position, at that time this strip is connected between common and NC pin, right? There is a connection between common and NC pin. And this side we see there is A and B. These 2 pins are there. In relay also it is denoted as A and B. So if here in this second diagram we can see, if this B we connect to the ground, and suppose this relay is a 5 volt relay, this is 5 volt relay, and we apply this 5 volt to this A pin, then a magnetic field will produce in this relay, in this region. So what that magnetic field will do, it will attract the strip, and now the strip will come in contact with normally open pin, right? Normally open pin. So now the connection is established between common and normally open pin of the relay. So this side where we are having A and B, here we are having low voltage, and this section of the relay where common NO and NC pins are there, this is our high voltage section. Here we can connect high voltage device. So this is the relay, one of the relay board which is available in the market. We can purchase it. It comes in around 60-70 rupees. So here this blue color, this is our real relay is there, and this is my NC connection, normally closed connection. From here we can connect to the normally open pin. This is NO and this is the common connection, right? And this side, for low voltage side, here this connection has to be connected to the 5 volt, and this is connected to the ground. So basically you can say that this is my pin number B, and middle pin in, this is my pin number A. So now pin number A, if I will connect to the Arduino pin, suppose pin number 11 of Arduino, right? And I will make that pin number 11 as a output pin. I will connect this pin number, I will make this pin number 11 as an output pin. So from pin number 11, I can generate 0 volt or I can generate 5 volt, because this is a digital pin. So when I will generate 0 volt, at that time, relay will not trigger. Relay will be in off position, because you see this A, here it is having 0 volt. B is connected to ground. No current will flow in this coil. No magnetic field will be there. So the common and NC pin will be connected with this strip. And if we, from pin number 11, if I generate 5 volt, and so this 5 volt will trigger the relay, and the connection between common and normal open will be established. So with this, this is the connection which I have made. This is one bulb. I have connected to 220 volt AC, and this is, see, like this, and this is a pin. This is one wire. This I have connected with bulb, and this side of the wire I cut here, right? So what we have to, how we have to establish the connection? This wire, one end of the wire must be connected to common, and the second end of the wire, it can be connected to NO or it can be connected to NC. It does not matter. You can connect with NO or NC. Only thing is the operation will reverse. That's all, right? So in this way we have to make this connection. So in the same way I have made the connection here. You can see here this is connected to common, and the second wire I have connected to NC, right? And pin number 8 of the Arduino I have connected here at the end, which is basically A pin of this relay. So now when the relay is not triggered, under what condition relay will not trigger? When the Arduino pin number 8 is generating 0 volt. When it is generating 0 volt, relay will not trigger. If the relay will not trigger, so this is the connection. Basically, common is connected with the NC with the strip. Now you see how I have made the connection. I have connected the wire to the NC and the common only in this connection. You can see here. Here this is common and this is NC. So now you can see the connection is complete. This connection is complete, right? So our bulb will on. This is the condition. And if from the Arduino pin number 8, I will generate 5 volt, then what will happen? You can see here. See this pin number 8. Here I have generated 5 volt. So it will trigger the relay. So relay will be triggered. Now the magnetic strip, it will establish a connection between common and anode. Now we can see this connection. What is the connection? Whether it is open or closed. So bulb is connected with the common. Now this, see here, this is common to NC. This is open circuit. So if this is open circuit, connection is not established and bulb is off. So simply we can turn on or off this bulb, which is a high voltage device. So here I will just demonstrate how I am doing this, and later on we can use the sensor value. We will process those values, and according to those values we can make the decisions, right? What we have to do. So here this is a simple program. So we can see, you can see here this pin number 8, right? Pin number 8 is declared as output, right? And here I have used the function digital write. When we are using digital pin, at that time we will use the digital function. So digital write, control word means pin number 8 low. At pin number 8 we will generate low value, means 0 volt. So when we will generate 0 volt, then what will happen? You can see here, relay will not trigger because Arduino 8 pin number 8 will generate 0 volt. Relay will not trigger, and this connection is complete. Bulb is on. Now you see, after that I have written delay 5000. So this will give me a delay of 5 seconds. So bulb will on for 5 seconds. After that, the next statement, digital write, control bulb comma high. So now pin number 1, at the pin number 8, I will generate 5 volt. So when 5 volt is generated, then what will happen? We see this figure, this Arduino pin, it generates 5 volt, relay will trigger. So strip will make a connection between common and NO pin. There is an open circuit condition, so bulb will off. So this, I will just demonstrate this program. Okay, so now I will demonstrate how we can interface a bulb and a relay system with Arduino. Now here we know that Arduino board generates a low power, low voltage AC in the range of 0 volt to 5 volt. But since we have to operate here a bulb which is operating at higher voltage AC, that 220 volt AC, so in order to perform the operation of this bulb, we have connected the bulb through relay. So relay operates by using a small voltage and it controls the higher voltage flow. So now you can see here, this is a relay. Now in this relay, these 3 pins, 1, 2, 3. Here the middle one is common, and this right side, this is normally closed, and left side, this is normally open. So what I have done, I have connected my bulb to common and normally closed. So in this way, what will happen, when the relay will not trigger, when the relay will not operate or relay is not on, under that condition, bulb will be on. And when the relay will trigger, at that time, common and normally open terminal will be joined, will be connected. And in that case, bulb will be off. So now, and now you see here in this relay board, this green color, wire is connected to VCC. Then left side wire, this is red color, is connected to ground. So this VCC and ground is used to give the power to the LEDs and other transistor of this relay board, right? And the middle wire, that is orange color, it is coming from pin number 8 of our Arduino board. So if the pin number 8 is logic 1, that is 5 volt, then the relay will operate, and if the pin number 8 is at logic 0, then relay will not operate. So I have already written a program, and in the program the bulb will on for 5 seconds and it will off for 8 seconds. These timings I have given. So now I will demonstrate you this program. Okay, so now I will on the relay. So now you see bulb is on. It will remain on for 5 seconds. Now it is off. It will remain off for 8 seconds. Now on for 5 seconds. Now if I change the timing in my program, suppose I want to make the bulb on for 2 seconds only and off for 2 seconds. So I am simply changing the timing in my program, and again I am downloading the program in the Arduino board. It has been downloaded. Now you see bulb will be on and off for 2 seconds. Now if I again change the program, on 1 second and off 1 second, simply I am changing the timing and I am dumping the program once again. Now you see 1 second on, 1 second off, 1 second on, 1 second. Okay. Now we will see one sensor, and finally I will show this sensor application by using one relay also. So this is LDR, light dependent resistor. Okay, so this is LDR, light dependent resistor. So you can see it looks like this. It has two terminals. This is terminal 1 and this is terminal 2. These terminals are interchangeable, right? So any terminal can be connected to VCC or ground. Now here we can see this is a cadmium sulfide track. This somewhat orange color is cadmium sulfide track. So basically here the working principle here is, for this device, suppose this is the conduction band and this is the valence band, right? In between there is forbidden gap, EG. In the valence band, electrons are filled in the valence band. Valence band is filled with these electrons. Now if some light falls over this material, then few electrons may gain the energy and they may jump from valence band to conduction band. So electrons will come in the conduction band due to these photons. When these photons falls over these electrons which are in valence band, electrons will gain some energy and they will cross the forbidden gap. So suddenly what will happen when photons will fall over this LDR, then suddenly the number of free electrons in the conduction band will increase, and if the number of free electrons will increase, then its conductivity will increase. So basically its resistance will decrease. So when the light will fall, then resistance will decrease. So here also we can see in this diagram here, on x-axis I am showing the light intensity, and in the y-axis I am showing the resistance. So if the light intensity is increasing when we are moving from origin toward this side, then light intensity is increasing. So when the light intensity is increasing, the resistance of this LDR is decreasing. Resistance is decreasing. So why it will decrease? When light will fall, the basic is this: electrons from the valence band, they will come to the conduction band, and suddenly the conductivity will increase, right? Okay, so this is the basics behind this LDR, and how I have connected this LDR here. You just see it will be connected in this way. This is LDR. One end of the LDR I have connected to plus 5 volt, and this second end, at this second end I have connected another resistor. I have connected another resistor, and this resistor is connected to ground. This is R. This is fixed value resistor. Its value is fixed, whereas the value of resistor LDR will change depending upon the light condition. And from this junction I will take the output, right? I will take this output, and this I will connect to A0 pin of Arduino. So whatever is the voltage across this fixed resistor, that voltage will enter inside the Arduino, right? So that this value of this resistor, this voltage will change, because depending upon the light condition, the value of LDR will also change. Depending upon that, there will be the variation in the analog input voltage, and from that voltage we can, after doing the processing, we can come to the conclusion that whether it is a day condition or it is a night condition, right? Accordingly, what I will do, depending upon the day condition or night condition, here I have connected one bulb through this relay, right? So if it is night, then this bulb will turn on, right? And if it is day, bulb will turn on. And how we will detect the day and night? With the help of this LDR. So the basic circuit, as just now I discussed, it is like this. This is 5 volt. This is LDR. This is fixed resistor. We have taken a resistor of fixed value 10 kilo ohm, and this LDR, its resistance is 100 kilo ohm in night, and in day its value is 500 ohm in day. So definitely in day means when the light will fall over this, then the conductivity will increase, so its resistance is less, and in night its resistance is more. Okay, so now we will see case 1 when it is night. When it is night, the resistance value of the LDR will be 100K. The value of R1 resistor is 10K. It is fixed. The supply voltage is 5 volt. This is also fixed. Now, if we apply the potential divider rule, then this V out, this we can calculate, right? This we can calculate, and its value is coming here 0.45 volt, 0.45 volt, and this we will connect to A0. So in night time, the analog input signal will receive a voltage, analog voltage 0.45 volt, right? And if it is daytime, then the value of LDR will become, the resistance of this LDR will become 500 ohm. The R1 is fixed, it is 10K. Supply voltage is fixed, it is 5 volt. Now, as per potential divider rule, we can calculate the voltage V out across this 10K resistor.
Excuse me, sir.
Yes, sir.
Mishra, sir. Sir, actually, next session is 6 to 8. So try to close. Sorry for the interruption.
Okay, okay, sir. So shall I close after this?
Yes, sir. Yes, sir. Yes.
Okay, so this V out is 4.8 volt. So this 4.8 volt, when enter in the Arduino from analog input pin A0, it indicates it is a day condition, right? And here I have written the program in such a way, if it is day, then bulb will off, and if it is night, bulb will on, right? Okay, so I will just see what are the other things. Okay, so here there is an optical sensor. So this optical sensor, it will it is having these LEDs. One is IR emitter LED, one is IR receiver LED, and it will also detect the obstacle, what is in front of it. But the calculation of the distance is difficult from this. With ultrasonic sensor, we can calculate the distance also, how far that obstacle. So its range is 2 centimeter to 30 centimeter. Then okay, then there is one touch sensor. So this touch sensor, its operating principle of the operation is based on the capacitance, right? When we touch this sensor, then suddenly our body conductivity will also come in the picture, and it will form one capacitance here, another capacitance, this, right? And in this way, the value of the capacitance will change, and accordingly we can sense it. Okay, and then this is humidity and temperature sensor, which detect both humidity and the temperature. It is DHT 11. Okay, sir, I end here then.
Sir, thank you.
Yes.
Sir, any questions from audience, participants? Ravi sir, any questions are received, sir, in the chat box? Dear participants, you can interact with the resource person. Dear participants, if you have any questions, you can ask. Anybody want to interact? You can interact.
Okay, sir. So thank you very much for
Yes, sir. Sir, your
patience
session is
hearing.
very nice session. It is very, yes, sir. Thank you for your accepting our invitation, and you spent very valuable time to our participants. Once again, thank you, sir.
Thank you, sir. Thank you very much.
Professor, thank you, Professor.
Kannan, sir?
Thanks for yeah. Am I audible, sir? Yes, sir. Audible, sir. Kannan, sir. Okay. Yeah. Thank you very much, sir. Yogesh Misra, sir. Thank you very much for your informative session. Thank you very much, sir. And also, yeah, Bharati ma'am is also there. Bharati ma'am, you are welcome, ma'am. Welcome to our FDP.
Thank you, sir. Thank you so much, sir.
Welcome, ma'am. You just give some. Good evening, madam. Good evening, madam.
Good evening, sir. Good evening, sir. Thank you for having me here, sir. Thank you, sir.
Let us begin by 6:05, madam. Until then, let us wait, madam. 5 minutes.